So let's just start with the manual. And if you look at that first kind of manual in a nutshell, here, page 5, what I want you to notice is we have these little kind of icons here: in an armchair, at the kitchen table, in the field, back at the kitchen table, in a chair at the table, in the field. What you can see is that most of the work that you do when you do research actually happens off field. It's happening at your table. It's happening, kind of as you're just sitting around. Once you get an idea kind of in your mind, it's just going to roll around up there. And you'll be at your computer trying to figure out, okay, what can I grow here? If I put in irrigation, like, how would it change my land capability? And all that planning needs to happen well in advance of you actually going out to the field when you're ready to do your research. And when you're ready to do your research, you have to stick to all this planning and don't forget about all the work that you did ahead of time. So it's important that you stick with the plan and you spend a lot of time, which unfortunately we're going to kind of race through the planning phase. But the good thing is we'll race to the planning phase this week, but then you have all winter to revisit it and make changes. And, we thought about it a little bit more. Like while I was at home for Christmas, I spent some time thinking about what I said I was going to do. And now I'm thinking I want to tweak this or tweak that. And then I'll just say like, yeah, sounds good. Or I'll say, no, stick with your plan. It was really solid. Don't worry. Like, don't doubt yourself and the work that you've done. Well, the first thing I just want to review is that I've called it the Guide to Demonstration Research or on-farm demonstration research, because within the research world, there's two types. There's classic research. That's what I'm trained to do, and it's sort of this type of thing, right? And this might be what people think of when they think of research. It can be very tedious and onerous and lots of failures, and you're trying to make it as absolutely clean as you possibly can. Get rid of all the variability that could be out there so that you can focus on one very, very specific thing that you're changing. So here people are planting, and they actually are planting, like you can see, they've got little divots here, and they're planting with the exact space between the plants because they don't want space between their plants. Right, only one thing that you're changing. It might just be like just the variety of plant. And then this is demonstration plots. And this is when you go out and a seed company or government will show you what you can expect in the region if you do this, right? So all this has already happened behind the scenes. They've already had lots of failures, and they now show you what you can expect if you plant this variety. A lot of the times in these big demonstration type plots, they've tested something across many, many regions, and now they're having a field day where they're going to show you, if you plant our seed variety, here's what you can expect here. You don't see the failures that happened in the background. All you have to do now is say, okay, I'll go buy that seed, because I can see what I'll get if I buy that seed, right? So what we're talking about with on-farm demonstration research is you're really doing a hybrid of these things. You're not doing classical research to the level of detail that someone at a university or a federal researcher might do, but you're also not guaranteed anything, right? You're still experimenting, still trying to figure out what might happen on your farm. It's very farm specific. So what you do is specific to your farm, your goals, where you want to get. And the more farmers that test an idea, then the more you can get towards this regional sort of expectations of, doesn't matter where you are in the caribou grow this variety, you'll have this kind of result. But that's not where we're at. Right now, we're at a very farm specific, what's going to happen on your farm if you test it. Okay, so for me, this is really what research is all about. It's about observing and then wrapping a question around that observation. It's about spending a lot of time looking and just formulating ideas and questions and being aware of what's going on around you. And that's when you can start to really get to some good research questions. It doesn't happen overnight, and that's why we start really small. But if you're not observing what's happening, it can be difficult sometimes to make sense of your research at the end, because research, the best laid plans almost never go that way. So you have an idea, you spend all this time writing out step by step how it's going to be, and then something happens and it goes sideways, or your results aren't as clean as you hoped that they would be. So the more time that you spend throughout your research really observing what's happening and making field notes, the easier it will be to make sense of your results at the end. Okay, so really what research is all about is trying to predict future responses. So trying to say, okay, I have some confidence that if I do this, I will get this result. If I fertilize with this fertilizer combo, I will get improved yield. If I do no-till, I will get improved soil health. So you're trying to have some confidence that the results that you got will happen year after year after year. And so that level of confidence will be affected by things like variability, which we'll talk a lot about variability. It also, your level of confidence is also closely linked to how well you sample your population. So a population is just a group of something somewhere, right? Like you have a population of little mice crawling around on your head. We all know that, right? We have a population of students in this classroom right now. We have a population of dogs that run around Williams Lake at night, right? So you have populations and they're somewhere. So you put some kind of boundary around it because what you're studying is my population of alfalfa in this one field. You can't sample every single alfalfa plant, right? It just doesn't make sense. That would take you forever. So you want to sample enough of the population that you have confidence that the numbers that you generated from that population really do represent the population. So you might say like, well, if I walked into this classroom and I said, okay, I want to know what the population of this classroom is, and then I pick one student and say, okay, here you are. Everybody in this classroom is just like this person. They all have long brown hair. They're all 5'3". Or everybody in this classroom is just like David. They're all 6 foot something. They all have gray hair. They all wear glasses. It doesn't make any sense, right? You know that you have to sample more than just one thing because there's all this variability, right? There's male, female, tall, short, big, small, big feet, little feet. Doesn't matter. So you have to get a true representation of the population. And then when you feel like you'll know that because that will be reflected in your data. And then you can have confidence. You can say, I know that I really sampled a good representation of my population. And so my numbers truly reflect what's going on out there. Then, of course, the more times you repeat the experiment, the more confidence you'll have. If you do it just once, you might wonder, well, kind of a wet year. Well, it was kind of a dry year. So if you can do it more times, you'll have more confidence in your results. But you might also be like, I did it once and the results were such a slam dunk that I'm going for it. Like this, I have so much confidence in results. Okay, so this is what I was saying before. You want to sample enough of the population that you have confidence that you truly have an accurate representation of what's out there. And you need to sample the population in a way that's unbiased, right? One of the things that we have a really hard time with is that our eyes control our body so much. And it's hard not to be steered. And so if you're sampling the population, and I've even had producers do this, and I've been with them and they've thrown the hoop, and then they've gone over and been like, I don't like that. Then they picked it up and thrown it again. You can't do that. You can't say, I don't feel like that really represents what I thought I was going to get out here. So unless you throw the hoop and it lands on a road or a wheel rat or something that's so weird, that big rock that you could never move from the field and you're always working around it, that's a reason to pick the hoop up and say, okay, this is such an anomaly. I'm not going to sample here. But otherwise, where it lands is what you've got. And so you can't let your eyes dictate what you do, because sometimes you actually don't see what's happening, and it's not until you collect the data that it starts to come alive and you see like, wow, there actually is a big difference here. I didn't even, when I looked at the field, I couldn't see any difference. So let that hoop guide you, like if you're throwing a hoop out and measuring yield, just walk to wherever the hoop is. Don't bias your results because of what you think you're going to find or what you want to find or what you hope to find. Just let it run its course. Okay, so you want to sample enough of the population that you have confidence in your results. And so this is just like a standard height and weight children, right? We've sampled so many kids in so many places. And this is probably a North American thing. This would be different if you were in like Somalia or somewhere else, but so that we can come up with an average here. But you can see that there's still lots of variability around that average, right? And that there's, some kids that are tall and don't weigh very much, and there's some kids that are tall and weigh a lot. There's some kids that are short and weigh quite a bit. This one is 56 inches and it weighs the same amount as somebody up here who's 64 inches. So there's some natural variability that's going to happen, and there's no way around it. But what you want to try to do is limit that. You want to work with natural variability, but you don't want to increase here, right? Like you might want to avoid sampling kids that were premature birth, right? Because they may always be really small. And so there's going to be some weird outlier here that's going to make your data kind of weird. So you want to avoid that. In a farming thing, it might be you want to avoid putting your plots right through a big saline patch in the middle of your field, right? A spot where nothing ever grows or where all you ever have are weeds. Well, don't stick your research right in that weird patch, because it's going to give you ahead of time, right? You already know it's going to give you weird results. So just avoid it if you can. So here's some examples of variability. So there's landscape variability, and it's everywhere. And if your landscape that you're working on in your farm, just if it has a lot of variability, well, don't try to ignore it or avoid it. Don't pick the flattest little section of your farm for your research if 95% of your farm is rolling hills. Because whatever results you get from that 5%, on that one sort of like nice little dreamy section of your farm, it's not transferable to the rest of your farm, right? Because you've done your research in a spot that does not represent your farm. So pick the areas, do your research that you feel represent the majority of your farm, so that you can transfer those results to other locations in your farm. But avoid real weird spots, which we'll talk about later. So we can see here, right, in this middle section, they've got some good growing areas, and then what happened here? Like You don't even, that's where understanding your soils becomes important. Maybe, who knows, something happened there. So if that, you might decide like that's a totally, like all my farms, all my fields look like that. I need to incorporate that somehow. But don't make this treatment A and this treatment B because already, treatment A trump treatment B, not because of the treatment, but because there's something in the soil here that's already affecting everything. So instead, you lay your treatments across, so both treatments get equally crummy soil and equally good soil. Now, here's an example of natural variability that happens even in the most ideal conditions. This is wheat yields from a flat and uniform field. This work was done in Oregon. So these are literally like lined up beside each other across a big field. And you can see that we went from 55 bushels per acre all the way up to 70 bushels per acre. And there's nothing about that field that indicates there's anything different between these plots or these, seeding. They seeded the exact same wheat, the exact same, seeding rate, everything's the exact same, but there's just this subtle variability across that field, even though it's flat and uniform and should be all the same, but it's not. So there is going to be variability that you can't see, you can't predict it, and that's why we try to make our plots big enough so that that natural variability is hopefully present in everything. Okay. So with variability, the key is to design a project that will have results that are strong enough to overcome that subtle natural variability. So you want to test two things where you're expecting the results to be so far apart, like this one gets this yield and this one gets this yield, that even with that little variability that can't get away from, they're still different from each other. If you test two things, like I'm going to test seeding my field 12 pounds to the acre versus 13 pounds to the acre. That's so, like, the amount of error in your seeding equipment is probably 2 pounds to the acre right there. So the test that you've done, those two treatments aren't actually even different from each other. And then the variability that's in the field already, and the variability that's in equipment, there's no difference in your treatment. They're the same thing. So pick things that are really significantly different from each other. Like one of the case studies in here, Wayne Ray, he seeded 12 pounds to the acre versus 25 pounds. Right? Like that's huge difference. And he got hugely different results too. So we know variability is everywhere, and we just do our best to minimize its impact, either by avoiding really obvious variability or sampling enough of the population that we can see how that variability looks. Yeah, there's lots of on-farm variability. Do you try to sample your soils and then blend it and say this is the average of kind of what I've got here? Or do you take soil samples and keep them separate so that you know this is the good spot, this is the crummy spot? And that comes down to what are you doing on your farm, and what level of detail is required. If what you're doing on your farm is planting, one type of alfalfa across all your fields, and you love that variety, and time a field comes up for replanting, you plant that same variety, then why do you need to know how the soils vary? Because you're not changing anything, right? Like you're not going to say, well, if the soil here is good, then I'm going to do something different here versus here. You're doing the same thing regardless. So really, you only need a basic idea of what soils are like, because you're, yeah, right, into soil sampling. Yeah, because soil sampling, well, it's like around $5 a sample, I think. People are like, ooh, that's so expensive. Well, how much do you spend in seed every time you reseed a field? A whole lot more than $65, right? So that investment, while it may seem sort of unnecessary or like, oh, that's a waste of money, it's actually a huge benefit. And when people get in the habit of soil sampling, I think they never go back, right? They're like, why did I never do this before? Um, so that, that's kind of, and that's the thing with, precision agriculture and how much do you want to divide your fields up, that really comes down to you. How much do you want to start looking at your fields as sort of micro fields, or, like I'm going to chop that field in half, or I'm going to, seed heavy over here and light over here. That's up to you guys. But it is something to consider for sure. There's nothing just because there's a fence that goes around an 80-acre field. That doesn't matter. It doesn't mean you got to treat it. And, that fence is just there because somebody stuck it there. Doesn't mean you have to keep working that field like one block the way that the fence line is shown, right? So that's a great question. Thanks, David, for bringing that one up, because I think that this is something that you need to be really thinking about. Think outside the box. There's fence lines. There's all kinds of stuff out on the farm. Get rid of it all and start thinking in terms of the soils and the land capability and how you can manage that farm maybe a little bit differently based on what is there, not what's been put there, right? The soil is what's there. Everything else has been put there and whatever you want. So this is rule of thumb that you want your plots to be 500 feet long because it will capture this variability in the landscape. That's just a rule of thumb. Like I was telling you guys with the kale producer example in here, his plot that he did for kale was probably half an acre, not even, maybe a quarter of an acre. It was tiny. And he said, like, if I'm going to try planting kale and Vanderhoof, that's all I'm going to risk manage. If I have a total crop failure here, okay, I can handle, a patch of weeds here next year, but I'm not going to plant a big chunk of my primo land, something that I don't even know if it's going to grow or not. So, but 500 feet is great if you're dealing with a crop that you already know is going to grow, and you're just changing something like your seeding rate or, your timing of harvesting. You want to try, like, can I get 3 cuts out of it instead of something like that. 500 feet allows you to get that subtle variability across the whole thing so that you capture some good spots, some bad spots, a little bit of this and a little bit of that across the whole thing. If your treatment is too small and you've done like A here and B here, and A happened to be in a bit of a depression and B happened to be on a bit of a hill, you can't see it with your eye, but there's this subtle difference. And this one gets just a little more moisture and that one's just a little bit drier. Well, and now that little bit of variability that you can't even see with your own eye is affecting your results and you don't even know it. And then you might think, oh, there's no effect of my treatment, but it's because that little bit of moisture actually overrode your treatment effect. So you want to make it big enough that the good and the bad all get put in the mix. So this is where repeating your experiment and your confidence in your results starts to come together. Is if you have this question mark at the end with your results of, well, did I get that because it was kind of a wet year this year? Or gee, we had a really dry year. Then if you're asking yourself those questions at the end, then it would be good to repeat the experiment and start to see, does this happen year in, year out? You can't, unfortunately, you really can't control the climate. You can't make it rain when you want it to rain. That's also why it's really good to have your plots side by side, right? Don't stick a plot here and one kilometer down the road in the other field, because precipitation is highly, highly variable. Even if those two fields seem exactly the same, I mean, they're not, but even if they seem exactly the same, the amount of rain that comes is so variable around here that it can be dumping here and a kilometer down the road it's bone dry and that rain never reached that spot. So put them side by side so that if it rains, chances are it's raining in that 5 acres or 10 acres. But if you don't have confidence in your results and you think it's linked to climate, then try repeating it. Hopefully the results you get are strong enough that whether it's a wet year or a dry year, you'll have confidence. Unfortunately, we have to be thinking about climate change. There's no way around it. There is no normal anymore, and we'll see that when we look at some of the climate data. There's no normal, and the weather is so unpredictable that you're just going to have to roll with what you get year to year. And hopefully, when you guys do your experiment, you'll get relatively normal weather. I put that in quotes. But if not, just try to repeat it, or maybe even try to make sense of it. Okay, so this is what I want you guys to do. Everybody brought your laptops or have access to a laptop. So this is an example. This is a real life example of what happened when I did this project up in Vanderhoof. So a couple years ago, that's where this whole manual came from, BC Forage Council. They were the brainchild of the manual and doing some on-farm demonstration research in Vanderhoof, and I worked with 4 participating producers. 3 of them are in here as case studies. You can read it. This is like they did the work, so you can do it too. But this was one of the producers, and when we Googled the field that he wanted to use for his research, this is what he sent me. This image, and I looked at it and was just like, oh, you guys should be able to see how incredibly variable this field is. There's a pond right here. There's some kind of a gray saline something, I think, patch here. These are old slash burn piles from when they cleared the land. The edge is like all convoluted, and this forested patches. It's a mess. It's an absolute mess. And so then I said to him, do you have any other field? Let's look on Google and see what else you've got. And he's like, well, I have this field right here. I'm thinking about tilling up. Oh my gosh. Right? Like I was like, say, so this field is, from the air anyway, relatively flat. It has this little convoluted edge, but that's fine. We avoided it. It's got nice square boundaries. It's got some trees here, but we set everything far enough away from the trees that we weren't impacted by it. Not a lot of roads going through it. He's just got his perimeter road so he can access stuff. So I want you guys to go into Google Earth or Google Maps and put on the satellite view. Find your farm, wherever you're going to do your research, and look at the fields from the air. Now, some of them I know are going to be like, oh, well, is this being harvested or what, when they took the photo. But look at the fields and look for what you think, which field do you think could be your candidate to do your research in. Just strictly based on this kind of aerial view of some of the really, really obvious variability in there. So things to look for when you're looking on your field. If there's green swales, you know that you've got water that's traveling through, and so that water is going to be an anomaly that you want to avoid. You can kind of see dry, bony areas that look like something scalped it. So those are also spots that are, it's good to be aware of it. Doesn't mean that you have to throw it out. But things that you should be really concerned about is this, I couldn't have asked Wayne to send me a worse field than my starting field. right? Because those flash piles, those are affecting all the soil nutrients and the water and the saline and the edges. I mean, it's just, there's so much going on there. You guys don't need to finalize anything right now. I just wanted you to go through the process of going into Google Maps or Google Earth, looking at your field, seeing what they actually look like, because you can see a lot of details from the air that you can't see from the ground. You're still going to have to go back to the farm and actually walk these fields or you finalize which fields you want, because you can see a lot of things from the ground that you can't see from the air. So you got to do both. But I just wanted you to know how to do it, what you're looking for, what you want, what should be absolute red flags for you. Field variability, a little bit of topography, sloping hills, that's no big deal. But this is kind of a deal breaker. You can't find a spot to put a plot in here because there is so much incredible variability. Not subtle, but like incredible variability there. This is for me right here, this is awesome. Okay, so you've got that little tool now. So I want to summarize this and then get partway through chapter 2. So like I said, this on-farm demonstration research is really farm specific. Really important that you really think about yourself and what you need and what your farm has. Don't worry about what your neighbor says you can or can't do, because they don't live on your farm, right? The soils are incredibly variable, the climate is incredibly variable. The historical management of each farm is highly variable. So you can have two farms that, for whatever reason, actually are identical, but the management hasn't been identical, guaranteed. So what your neighbor says can and can't be done, that's up to them. You are starting with a clean slate, and you're going to figure out what can and can't be done on your farm. You need to sample enough of the population to have confidence. So we're going to talk a lot about sampling later today. Variability exists. There is no way around it, but you want to either incorporate subtle variability or avoid extreme variability. Well, you want to incorporate subtle and avoid variability. And ideally, you would repeat the experiment. That doesn't always happen. In fact, it often never happens. But where you would repeat it is when you are feeling really unsure of your results, you want to do it again. And that's why it's important to start small and to start with a really simple project. Something where you feel like you can do it and not feel like you dropped the ball, right? It's easy to bite off more than you can chew and to get really excited and say like, yeah, I'm going to do this and this, and I'm going to measure soil moisture and soil nutrients and yields and weight gain on my cows. And then the time comes and you're under pressure to get all the other stuff done that you have to do, and you don't get anything done, right? Or you do it in a way that you have no confidence in the results. So start really small so that you can have a success and have real confidence and go forward from there, building and building a little bit more, a little bit more. The confidence that you get in your results will open up like 10 more research questions. It never ends. You're now all in my research web. You're now going to be like, oh no, why did I take that class? Because now I can't stop. Like I've got these results and I just want to keep building on it and building on it and building on it. But you need to start with the success, right? So that's why we're going to do this, so that you guys will start with a successful project and have that confidence doing the research. So that's chapter 1 in a nutshell. So now we're going to move on to chapter 2.